Yes, hello, Mr. Navshad Sohel. Welcome on YourPedia platform, and let's start your heat transfer snap for your final JKPSC interview for
Yes,
the
sir. Thank
post
you,
of
sir.
Assistant Engineer in Public Works Department.
Yes, sir.
So, Navshad, give me some application of heat transfer.
Sir, heat transfer, sir, actually, which it is in every day-to-day normally what we use, sir, in refrigerators, sir, in heat engines, in sir, heat exchangers, that is the radiators that we use in automobiles, or we can say, sir, in the our these in cooking purposes, on those, sir, instruments, and sir, in laboratories everywhere, sir. Day-to-day application we have.
What is required solve for the transfer of heat?
Sir, as there are different modes of the heat transfer. Sometimes we may require, sir, the material medium, or sometimes we do not. That depends upon the how we are transferring the heat. For example, in conduction we may need some solid surface, or sometimes liquid surface, but that is very complicated case. And sir, in convection we might need fluid, and in for example, if we go for the radiation, we might not need, we do not need the material medium in that case, sir.
Okay. Navshad, you heard about can you write the generalized heat conduction equation in Cartesian coordinate?
Yes, sir. Yes, sir.
Go ahead.
Cartesian coordinates, sir. How do we write it? We write it T Q by. How we write it? General heat Fourier's law. Sir, right now I'm not able to grasp
it. Generalize the heat conduction equation in Cartesian coordinate.
Sir, I'm not able to get it right now, but sir, I will try. How we used to write it? Del square Q, del square T. Sir, right. I studied it, sir, but right now I'm not, sir, able to.
You heard about thermal conductivity?
Yes, sir.
Can you define this, and please tell me the various factors which affect the thermal conductivity?
Sir, the thermal conductivity generally, sir, it depends upon the temperature, sir. It depends upon it depends upon the density, but densities in turn we can have the relation in between the density and temperature, and sir, we can say it depends upon the sir, crystal structure, sir. And it sometimes we can say it also depends upon, sir, pressure.
Conductivity, you are saying it depends on pressure also. How?
Sir, we cannot say it has a direct relationship, but sir, if we are able to increase the density, for example, the density has the direct relationship with the this, sir, conductivity. In case of the gases, sir, the conductivity decreases on this. Now, in case of the liquid, the conductivity decreases on increasing the temperature. That is, sir, because the density of the liquid is decreasing, sir, and the density can also be increased if we are able to, sir, pressure the liquid in some of the cases, not all of the cases, but in some of the cases, if we are able to increase the density of the liquid via the pressure, in that case, it is possibility, sir, this thermal conductivity can increase, sir.
Navshad, what is heat pipe and how it works?
What, sir?
What is a heat pipe?
Heat pipe? I don't know, sir. Heat pipe.
You not heard about heat pipe?
No, sir. Sorry, sir.
What is thermal diffusivity, Navshad?
Sir, the thermal diffusivity, we can say, sir, it is the ability of the body to conduct heat with respect to the ability of the body to store the heat. Sir, it gives us the idea about how much is the capability of the body to transfer heat through it. And sir, we define it as a ratio of the heat conducting ability to the heat storage ability of the body under study.
Can you tell me about convection heat transfer?
Yes, sir. The
mechanism of convection heat transfer.
Yes, sir. Sir, the convection heat transfer generally, sir, we can say that it is not an independent, sir. It is we can say it is a combined form of the conduction and, sir, the advection. In convection, conduction, what happens? The heat transfer, the transfer of the heat into, sir, if we define it on the convection में sir क्या होता है कि sir, actually the fluid which is flowing over some, sir, hot surface from where we want to, yes sir, you calculate the transfer of the heat. As there is the no slip condition on the surface, we can say that there the first layer of the fluid, the heat will conduct from that, and from that, after that, there will be bulk movement of the fluid, and that will lead to the advection. And we can say, sir, the convection is combined form of this advection and conduction, sir.
Okay. Naushad, what is Prandtl number and what is the significance of Prandtl number in heat transfer?
Sir, the Prandtl number, sir, generally mathematically, sir, we define it as the molecular diffusivity of momentum and the thermal diffusivity of the momentum. Sir, it will generally give us an idea. It is used in the thermal boundary layer concept. Sir, it will give us an idea about whether the hydrodynamic boundary layer is dominant in the fluid, or we can say the thermal boundary layer is much, sir, thicker, which gives us idea about the in particular fluid whether the momentum, this thermal momentum transfer is happening more rapidly than, or the viscous effects are the dominant in that, or we can say, sir, yes sir.
What is fouling?
Sir, the fouling, sir, is the actually the resistance that is, sir, due to the scaling and sedimentation that happens, that occurs in the pipes of the heat exchanger, or some, sir, the tubes through which the fluid is transferring or moving, sir. And
so
the fouling,
how we consider the additional conduction resistance offered by scale or fouling?
What, sir?
How we compensate the additional resistance offered by fouling?
Sir, we mathematically, sir, we add that is called the fouling factor, sir, and that is, sir, equal to 1 by HA plus, sir, I am not sure what it is equal to mathematically, but sir, we consider it by sir, adding the fouling constant. We say fouling factor, sir, to the mathematical relationship. Yes, sir.
What's the difference between a double pipe heat exchanger and a shell and tube type heat exchanger, Naushad?
Double pipe, sir, in double pipe heat exchanger, sir, we generally, for example, if we have to transfer the fluid from the in case of the if we have to transfer the heat between the two fluids, in one case, in double pipe, sir, we transfer the hot fluid from the one pipe, and parallelly we sir, make the cold fluid to move either parallelly or in, sir, in the opposite direction, so that the fluids will transfer the heat in between them. But in, sir, the shell and tube, what we do, sir, we make the fluid to move from the pipe, and for example, the second fluid through which where the heat has to be stored or transported to, that is, sir, that moves over that, sir, over that pipe, which does not that is open. I mean to say, sir, that does not need the pipe in case as needed in the first case.
Okay. Naushad, how the bowling is different from a basic, or what you can say, general convection case. In bowling also heat transfer takes place.
Yes, sir.
So what is the difference between general convection and boiling?
General convection and boiling, sir. सर जनरल कन्वेक्शन में तो 2 होता है, और सर बॉइलिंग में, सर बॉइलिंग आई एम नॉट श्योर, सर, बट सर
they are also the type of convection, or they are considered in some different mode?
Sir, boiling happens because of there is an equilibrium of the pressures between the surroundings and this saturation state, well, sir. But right now, sir, I need to look in this, sir. I am not sure, sir. I cannot define it right now, sir.
What is shape factor, Naushad?
Sir, the shape factor, sir, it gives us an idea about, for example, if there are, sir, two bodies, A and body B, and we want to, sir, calculate how much the heat that is emitted by the body A is falling on body B. So what we do, sir, we take the shape factor in which we are able to calculate the heat that is emitted by some, for example, body A, and how much part of that heat is, sir, getting that is irradiated on the body B. And sir, it depends upon the geometry, or we can say the placement where it is placed with respect to that body. Sir, it gives us an idea about that, sir.
So, in radiation also we observe some kind of resistances.
Yes, sir.
So what kind of resistances we observe in case of radiation?
Sir, generally there are two kinds of resistances which we study in heat transfer. Sir, one is the surface resistance, and another is the space resistance. The surface resistance generally depends upon the emissivity. As we know, the emissivity of the body is not 100%. So there are some certain resistances which are due to the irregularities in the surface that, sir, add to the resistances. And another thing is that as we lose, we are not able to transfer all of the, for example, if body A is radiating certain quantity of the radiation, and sir, the body B does not receive all of it. So we observe that, scientists observed that there is some part of this radiation that is lost in the space, and sir, that those losses we consider that in the space, this resistances. And sir, yes, sir, surface and space resistances, sir.
What is Kirchhoff's law of thermal radiation, Naushad?
Sir, Kirchhoff's law of thermal radiation, generally, sir, it says that a body which the absorptivity of the body at a particular temperature, thermal equilibrium, is equal to the, sir, the emissivity of the body. Generally, it says a good absorber is also a good emitter, and a bad absorber is also a bad emitter, sir, of radiation, sir.
Okay. My last question to you, Naushad, what are gray bodies, gray surfaces?
Sir, gray surfaces, I have studied the spectral emissivity. The spectral emissivity of a gray body does not depend upon the wavelength of the radiation, sir. Generally, sir, this is a kind of ideal body which is also, sir, considered in radiation, in which we say that the we can say the monochromatic emissive power of a body is not dependent upon the wavelength of the radiation, sir.
So, ठीक है Naushad, I think now I can provide you the feedback.
Yes, sir.
So Naushad, आपका delivery style ठीक है, you are looking confident, and most of the question also you answered. One, two very simple basic question you missed, like generalized heat conduction equation.
Yes, sir.
Heat pipe.
Yes,
okay.
Sir. Yes, sir.
And some basics of boiling also you missed.
Yes, sir. Exactly, sir.
I think remaining old question like the heat basic convection, mechanism of convection, thermal diffusivity, fouling related questions, those you answer.
Yes, sir.
Shape factor also. Gray bodies are the bodies which are having a constant spectral emissivity.
Constant.
What you can say, emissivity is not a function of, spectral emissivity is not a function of lambda.
Okay, sir.
For a gray surface, spectral emissivity is not going to change with lambda. Spectral emissivity is equal to emissivity for a gray surface.
Okay, sir. Okay, sir.
So boiling क्या होता है? Boiling is a special category of convection only.
Okay, sir.
Where one of the fluid changes its phase from liquid to vapor.
Exactly, sir. Yes, sir.
So boiling and condensation, those are considered as special categories of special case of convection. In convection, in general convection, we assume the heat transfer due to the temperature difference when there is a bulk motion of the fluid. One of the fluid move over the surface, maybe due to some kind of density difference, or maybe due to some kind of external agency,
exactly,
something like that.
Yes, sir.
But in boiling, the phase change takes place, and due to that, the fluid moves over the surface.
Okay, sir. I have to define the phase change in that.
Yes. In boiling and condensation, both. So those are considered as, because in that also the bulk motion will be there, but at the same time, the one of the fluid is going to change its phase.
Exactly, sir. Yes, sir.
So, and latent heat is much higher as compared to the sensible heat. In
Yes.
convection, general convection, the heat transfer which takes place, it is due to the sensible heat transfer, because the
Exactly.
phase is not going to change. That's why H value in general convection is lower. But if you talk about boiling and condensation, H value is very high. It is in lakhs actually. 1
Okay.
लाख 2 लाख के आसपास H की वैल्यू चले जाती है in case of boiling and condensation, because latent heat transfer is much higher as compared to sensible heat transfer. So H value, convection heat transfer coefficient in boiling and condensation is much higher as compared to general convection.
Yes, sir. Thank
These
you,
are
sir.
some of the things you can mention.
Sir,
Fine?
heat pipe also, sir. I don't know
देखो
about that.
देखो heat pipe क्या है? It's a super conductive. It is considered as a superconductor which is used for transferring heat.
Okay. Okay, sir.
इसमें क्या करते हैं? We use some kind of arrangement where one of the fluid boils actually.
Okay, sir.
And it,
Okay.
when it boils, it transfer heat from one region to another region. So at one region of the heat pipe, boiling takes place. That point will be connected to the surface where heat is generating, or
Okay,
where
sir.
from where you want to remove the heat. And
Okay, sir.
another end is connected to the other point where we are going to reject the heat. So condensation of the fluid is going to happen. So in
Okay, sir.
heat pipe, heat transfer takes place by carrying out the boiling and condensation of the fluid inside the tube.
Okay, sir. At the same time.
Yes, you can watch some video, you will get more idea. So those heat pipe are considered as superconductor. They are more compact. Okay, so their conductivity is very, very high. Heat transfer
Yes.
is very, very high. That's how we use them on some kind of satellites.
Okay, sir. Okay,
Those
sir.
are very much used in satellites for transferring heat. In our laptop also you will find heat pipes.
Okay, sir. Okay, sir.
तो
Thank you, sir.
लैपटॉप में भी हम क्या करते हैं? हीट पाइप्स को यूज करते हैं फॉर ट्रांसफरिंग इट. यू कैन जस्ट
Okay.
गूगल आउट, यू विल वॉच सम वीडियोस, यू विल गेट आइडिया हाउ
Okay.
द हीट पाइप वर्क्स.
Okay, sir.
Generalized conductivity equation you need to know, Navshat. Just go through the
Yeah.
equation in Cartesian, cylindrical, and spherical coordinates. Fine.
Yes, sir. Yes, sir. Definitely.
Remaining all question, I think you answered. You are looking comfortable and you are looking sincere, Navshat. Your
Yes, sir.
delivery style is also okay. I feel, definitely you will be able to crack this interview. Just be, prepared.
Yes, sir.
Revise all the subject. Watch
Okay.
marathon classes.
Okay, sir. Okay, sir.
And be confident, Navshat.
Okay. Okay. Thank you very much, sir. Thank you, sir.
Okay, Navshat. Good luck.
Okay. Thank you, sir.